In this session of CCNA series, I'll discuss about Cisco wireless architecture called Split MAC. In Split MAC concept, what an autonomous access point traditionally would do by itself is broken into two functions. Management functions such as client authentication, security management, association and reassociation or roaming, and quality of service. And the other function such as real-time function like transmission of 802.111 frames, MAC management, and encryption. Okay, the simple timing dependent real-time functions are managed by the access point, and this access point is called lightweight access point. And the less time dependent, that is management functions, are performed by the centralized controller called WLC or wireless LAN controller, which controls many lightweight access points. In this type of architecture, the AP is totally dependent on the WLC for every other WLAN function. The lightweight AP WLC division of labor is known as a split MAC architecture. In this type of architecture, every AP must boot and bind itself to the WLC to support wireless clients. To carry 802.11 related messages and also client data, WLC and AP use a tunneling protocol called CAPWAP between them. CAPWAP is also known as the Control and Provisioning of Wireless Access Point Tunneling Protocol. The protocol encapsulates the data between the access point and the WLC within new IP packets and can be switched or routed across the network. The CAPWAP tunneling allows the AP and WLC to be separated geographically and logically. It also breaks the dependence on a layer 2 connectivity between them. Here the AP and WLC can be located on the same VLAN or IP subnet, or they can be located on two entirely different IP subnets in two entirely different locations. The tunnel exists between the IP address of the WLC and the IP address of the access point, which allows all of the tunnel packets to be routed at layer 3. As the wireless network grows, the WLC simply builds more CAPWAP tunnels to reach more access points. CAPWAP relationship actually consists of two separate tunnels as follows. One is CAPWAP control tunnel and another one is CAPWAP data tunnel. CAPWAP tunnel control tunnel is responsible for messages that are related to the configuration and management of access point. They are authenticated and encrypted and uses UDP port 5246. Whereas data tunnel are used for packets traveling to and from wireless clients that are associated with the AP. These packets are not encrypted by default. So when data encryption is enabled for an AP, packets are protected with datagram transport layer security or DTLS, and it uses UDP port 5247. In order to avoid any addition of unauthorized AP to access your network, every AP and WLC must also authenticate each other with digital certificates. An X.509 certificate is pre-installed in each device when it is purchased. That's it for this session. I hope this was informative for you. Thank you for